Welcome to determining numbers of cells after incubation, or getting past, oh no, not math, I'll just skip this question and hope I get all the others correct. We all feel this. I understand, been there, done that. Which is why I'm making a video to walk you through some of the math that's going to be on the next exam. My objectives for this video is to help you learn how to use this formula that will help you determine the numbers of cells after a specific time of incubation. And then I'm going to give you practice in doing that. In overview, we're going to cover how prokaryotic cells divide, determining the number of cells after the time of incubation, how to take a ridiculously big number and convert it to scientific number format, and I'm going to give you practice with the style of questions that I'm going to be asking you on the exam. So let's talk about how prokaryotic cells divide. We call this binary fission. So one cell divides into two cells, and then each of these two cells divide into two more cells. So you start out with one cell, you end up with two, then in the next generation or series of cell divisions you end up with four. So we could do the math the long way and do 1 times 2 is 2, so going from the parent cell to the two daughter cells, you get 2. Then in the next generation, you take 2 times 2 is 4. And this works out when you have just a few generation times. You get much beyond 3 or 4, and then you have to start numbering them to keep track of how many times you've multiplied by 2. There is a formula that is much easier, and I'm going to walk you through how to use it. So here is the formula that I'm going to teach you how to use. And it's NT equals N naught times 2 raised to the N. So what does all of that math speak mean? So NT is the number of cells after incubation time. So N for number, T for time of incubation. N naught, or N0, is the number of cells that you start with before you start incubating. And then N is the number of generations. So let's go ahead and do a question, and I'll show you how to figure out what information you need and how to use the formula. Example of the style of question that you may find on the next exam in which you need to use this formula. So let's go ahead and read through it. You inoculate 10 cells into TSB broth at optimal temperature and nutrients which you provide. The cells will divide every 20 minutes. You incubate the broth for 24 hours. How many cells do you have after 24 hours? And I will always provide the formula, so you don't need to memorize the formula, but you do need to practice using it. Let me remind you what each of these things mean, and then we'll pick out what's important from the question. So remember that NT is the number of cells after the incubation time. That's what we're going to be figuring out. And then there's N naught, or the number of cells at the start. So let's take a look at this and see if we can figure it out. So you inoculate 10 cells into TSB broth. So that is the number for N naught. So we'll put that here. And then you need to figure out the number of generations. So you need to know that the cells will divide every 20 minutes and you incubate for 24 hours. So why do you need both of those? Well, because you need to figure out how many times the cells are going to divide in 24 hours. So the first thing that we do is figure out how many 20-minute intervals are in an hour. Well, there's 60 minutes in an hour, you divide it by 20 and you get 3. Okay, so for every hour, my cells are going to divide 3 times. I incubate it for 24 hours, so I take 3 times, that's the number of times the cells are going to divide per hour, times it by 24 hours, and I get 72. So N is 72. So if I plug these numbers into my formula, I get 10 cells times 2 raised to the 72. You were probably wondering how to do the math now that you've plugged it into the formula. So I'm going to stop my slide presentation here. And if you're using Microsoft, you can go in and you can pull up a calculator. I've already done that previously. And the default is this for simple addition. You can go into View and pick Scientific. So in scientific calculators, oftentimes you have this handy dandy formula button that will enable you to figure out 2 raised to the 72. So what you do is you click on 2, do this x raised to the y, you've already put the x in, and that's what this little caret sign is, and then you type in 72 and you get a really big number. And then you're going to times that by 10. So I hit times 10 and I hit equals and I get this huge number. Now, there's another way to do it. Suppose your calculator doesn't have a scientific view. You can go into Excel and do the same thing. But what you would do here is you would do an equal sign. So 10 times 2 raised 2, so I put that caret sign in, it's the Shift 6 key, 72. Now I'm not sure if my 10 is going to get multiplied by 2 before it's raised, so just to be sure I'm going to put parentheses around, and that gives me the same number. But you're going, no wait, it looks different. Well, we're going to talk about scientific notation, but let me close this up and we'll start the slideshow presentation again. Now that I've done the math, I've come up with this ridiculously big number. I can't even tell you what this is. Maybe it's a Google Plillion, I have no idea. But to make this easier to understand, what we do is we convert this to a scientific number format, or what we call scientific notation. So what I do is I take the decimal place, which is hiding out here, and I'm going to move it over to here. But I'm going to count how many times I move it. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22! So I move the decimal place over here, and I say it's times 10 to the raised to the 22. So the 10 tells you how many zeros are after this decimal place. Okay? Now you're going, well, what about all these numbers? Because of a thing called significant numbers, we generally only put between 1 and 3 numbers after the decimal place. These are the important numbers anyway. So that is scientific notation, so you'll be able to figure out what it is and be able to figure out how to recognize it on an exam. So let's do this first practice question. A food service employee rubs their nose without thinking about it and unintentionally inoculates 200 Staphylococcus aureus cells into the egg salad they are making. The egg salad is left at room temperature for 18 hours, I'm assuming accidentally, and each cell divides every 30 minutes. How many Staph aureus cells will there be in the egg salad after 18 hours? So here's our handy dandy formula. First thing we're going to do is we're going to figure out N0, or the number of cells we have before we start incubating. So that would be 200. So let's go ahead and put that down here. Next, we need to find the number of generations. So we know that it was unintentionally incubated for 18 hours, and the cells are dividing every 30 minutes. So the first thing is we figure out how many 30-minute periods are in an hour. So you take 60 minutes, divide it by 30, you get 2. Then we take 2 and times it by 18. Because there are 2 generations per hour, we times it by the number of hours, and we get 36 generations. So we do our times 2 raised to the 36. We plug this into the calculator, and we get this ridiculously large number, more than you would want in your egg salad. So we're going to convert this to scientific notation. So my decimal place is here, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it is 1.3 times 10 raised to the 13th cells. Here is another style of question that you may see on the exam. Once again, I'm going to suggest that you pause this video, do your best to figure it out on your own, come back, see how I figure it out. Then I would suggest that you move the video back, try it again on your own, and then go through how I did it. Repetition really does help. All right, so you take a culture from a burn patient to check for Pseudomonas aeruginosa. It's a common organism that infects burns, and you streak the sample onto agar. Colonies are not visible until at least 1 million cells are in the colony. So 1 million, if you write that out, so 1 with 6 zeros. Assuming 1 cell per colony and that the P. aeruginosa divides every 25 minutes, how long will you need to incubate the plate before you see colonies? So let's go ahead and underline the important part. So you're looking for 1 million cells at least. And then this P. aeruginosa divides every 25 minutes. And we're assuming 1 cell. So this one's different. I don't tell you the number of, well, I do tell you the number of starting cells. But I don't tell you how long. That's what you're supposed to figure out. So you can do algebra to put it in, but here's what I would suggest that you do on an exam. I've given you answer options, and what I would do is I would start with the lowest number and figure out which incubation time, or N, gives you at least 1 million or 10 to the 6th cells, a 1 with 6 zeros behind it. So let's go ahead and plug in what we can from what we have here, and then go ahead and figure out the different N numbers. So we know that 1 cell is our N naught, and we're going to times that. That's going to be times 2 raised to the N. Let's figure out the N's for each one of these. So in 1 hour, how many 25-minute periods are there? Well, 25 doesn't divide nicely into 60 minutes, so we go ahead and divide it, and we get not a full number. We get 2.4 generations. So let's go ahead and figure that out for 3. So you take 60 times 3 divided by 25. That's 4.8. Now here we've got to do a little bit differently, okay? So there are 24 hours in a day. You times that by 60 minutes to get minutes. You divide that by 25, and you get 57.6. You do the same thing for 2 hours. You can take 24, times it by 2 to get the number of hours, 48 hours, times it by 60, divide it by 25, and you get 115.2. So here's the question. When you go to N, do you round up or do you round down? Now, what you've been taught is if it's below 5, you round down, and if it's 5 or up, you round up to the next number. Well, when you're talking about generation times, you can't round up. So this one you would have rounded down to 2 because it's below 5, but here you can't round up to 5 because it hasn't finished a generation. So you have to round down to 4. This is the same thing. You round down to 57. You round down to 115. But you can't have part of a generation. You either have a full generation or you have to go down to the next full generation. So let's go ahead and plug in 2 and see what we get. And that gives you 4 cells, or 4 times 10 raised to the 0. In other words, we've moved the decimal place 0 times. If it's that small of a number, we generally just put 4. Now let's go ahead and plug in 4 as the N, and you get 16 cells. Once again, because it's a small enough number, I'm not going to put 1.6 raised to the 1. But when we put in 57 for the N, we do get a ridiculously big number, and it's way more than 1 times 10 to the 6th. So this would be your correct answer. I wouldn't even go on to the 2 hours. Hopefully this video has been helpful. I would suggest going back to this practice quiz and practice the math questions and get some practice in doing the math, especially if you're uncomfortable with it. And also, let me know if you have any questions. You can come to my office hours. I'm happy to go over the math with you again.